On Friday, we talked about the proportionality of similar triangles, and I mentioned that in similar triangles, all the angles are the same. Today, we're just focusing on angles. So the key idea for this, so in this top space, just write key idea. We're going to write the theorem that we're going to be working with. Key idea is called angle similarity theorem. The abbreviation for angle would be A. So sometimes you'll just see it as AA. Similarity theorem, that just stands for angle. And what this theorem states, and I'm going to be using a lot of abbreviations, I hope you're all right with that. Here's the idea. If two angles of a triangle are congruent, I feel like there might be writing on the wall. Oh, it stopped. Okay. Two angles of another triangle So if two angles of a triangle are congruent to two angles of another triangle, then the two triangles are similar. So what does that look like? I'm going to draw a triangle here, and then another triangle over here. So with similar triangles, remember they're not congruent, but they're proportional. So here are two triangles right here, and then the angles are equal. So what it's saying is if you know that two of the angles are equal, so let's say we're told that that's a 90-degree angle, and then this angle equals this one, then the third angle would have to be equal because 180 minus these two angles would equal this, and 180 minus these two angles would equal this. So the third angle has to be congruent as well. And then you can say that these two triangles are similar. So if two angles are matching, then you can say they're similar because the third has to be matching as well. And in similar triangles, the angles match. So we're pretty much going to be using angle measures to verify whether shapes are similar. And that's the gist of today's lesson. I already got that down. Okay, so now I'm going to zoom in on number 1. It says, determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. Okay, well, here it shows they both have a 90-degree angle here, 90 and 90. It shows that little box. It shows this one has a 48-degree angle and this one has a 42. So we're looking for two angles to be matching, but the two they gave us might not be the matching. Like, we need to figure out this third angle because this third angle might be 42, which matches this 42. So we're going to do 180 minus 90 minus 48. And when you plug that into a calculator, it does come out to 42. So this angle here is 42 degrees. So because we have two matching angles, we know the third has to be matching. So this has to be 48. And you could solve for it too. If you did 180 minus 90 minus 42, it does come out to 48, which is this angle here. So since the angles are matching, yes, they are similar. And then in terms of the similarity statement, we're going to write triangle. And then when you list the angles, you have to make sure they're in the same order for both triangles. So FHG is similar to triangle. And you have to go in the same order. I'm going 42, 90, 48. I got to go 42, 90, 48. So K, J, L. So that way everything corresponds. So you can use the similarity statement to find the matching angles. Okay, for number 2, same idea. They give us both, we have 90 here and a 90 here, so we have one angle in common. We're trying to see if we have another angle in common. We do 180 minus 90 minus 40, and I get 50. That's no bueno, because I'm looking for a 55. If I do 180 minus 90 minus 55, I get 45 again. So these three angles do not match, so not similar. These triangles are not similar. Okay. Next, for number 3, okay, it shows that this is 35, this is 35, so these two match. Let's see what this third angle is. 180 minus 35 minus 85 comes out to 60. 180 minus 35 minus 65 comes out to 80. Okay, so I got 60, 85, 35, and 65, 80, 35. They don't match, so not similar. So the angles have to match exactly. And then for, you guys got that in the work. Number 4. Okay, we got 82 degrees, 25 degrees. We got to figure out this third angle. So 180 minus 25 minus 82 comes out to 73. That is a good sign. So I have a 25 and a 73 on this one, 25, 73 on this one. Based on the angle similarity, I can already show that they are similar. But just for the sake of understanding the concept, 25 minus 73 comes out to 82. So this has to be 82. So yes, all the angles match. Yes, similar. And then triangle. And when I name these, I have to make sure to go in the same order each time. DEC is similar to triangle. And since I did 82, 73, 25, I got to do that again. 82, 73, 25. So STU. So sometimes on testing, they'll just give you this statement and they'll say, okay, what angle is equal to angle D? You can use this statement and say, okay, angle S is equal to angle D. So even without seeing a picture, if you have this statement, you can still find matching angles or matching segments. Okay, I already got it down. Next part. Okay, show that the two triangles are similar and write a similarity statement. So in these examples, it's going to show you different concepts that we've seen in geometry. So for number 5, it shows that 45 degrees, we have two matching angles here. And then remember, vertical angles are equal. So this angle is the same measure as this angle. So now you have two angles in common. So therefore, these two triangles are similar. We can say that triangle NYM is similar to triangle, and I have to go in the same order, ZYX. Number 6. With similar triangles and in geometry in general, they love to like overlap shapes. With overlapping shapes, often it's best to just like draw them separately. That way you can label them separately and their parts don't become confusing. So here's what I did. I just broke these up into two separate pictures so I can label them and actually compare. So this is the top triangle and this is the larger like all-encompassing triangle. So we have 45 here, 85. This is 50, and then this point right here, 85. So remember, we're looking for two angles in common. So if I do 180 minus 85 minus 45, I actually get 50. So this is 50. And then if you did 180 minus 85 minus 50, you get 45. So they do have all the angles in common. And so you can say that triangle XYZ is similar to, and so I started with a 45-degree angle, I got to start with a 45 over here, U, Y, W. W. Okay, one last one we're going to do together, and then it's more time. This one is interesting. It doesn't have any of the angles like labeled, but it does show two parallel lines. So it wants us to connect the ideas of parallel lines. Remember, with parallel lines, corresponding angles are equal. So this angle equals this because they're corresponding. And then this angle equals this one because they're corresponding. And then you could say that these are similar because they have two angles in common. Therefore, the third angle is in common, and so on. FYI, we're not going to write the whole like similarity statement or anything there. Okay, so I'm going to stop the recording here and get my mouse to work. What are you doing that?